Hello everyone, here is Afra. Today we are going to solve Cambridge IGCSE Physics Paper 4 Theory Extended, held on May-June 2021, and paper code is 0625 with variant 41. So let's start from question number 1. Question number 1. A skydiver of mass 76 kg is falling vertically in still air. At time t is equal to 0, the skydiver opens his parachute. Figure 1.1 is the speed time graph for the skydiver from t is equal to 0. Part A. Using figure 1.1 determine Part 1. The declaration of the skydiver immediately after parachute opens. So first of all, here we have to calculate the negative acceleration because here the speed is decreasing with the increase in time. So in this graph, it is a speed time graph and the slope of speed time graph gives us acceleration. Here we have to find out the acceleration. Therefore, I write here acceleration will be equal to change in speed and change in time. And this is basically equal to the slope of this graph. First of all, I have to find out the slope. So I draw a straight line starting from this point. So this line will be like this. And then we have take this point and this point. So when I take both of these points on y-axis, I also have to find out their corresponding time on x-axis. So this is basically at this point where it touches this curve, and I have to take its corresponding time, and it is 0.2 second and 0 second. I have to find out the slope between these 2 points. So I write here A will be equal to delta V, that is here V is 58 and at this point V is 50. So I write 58 minus 50 divided by delta time is 0.2 minus 0. So in this way the acceleration comes to be 40 meter per second square. But in the question we have to find out the declaration. So we have to put the negative sign with this value. So I write here minus, where minus sign shows that the speed is decreasing with the increase in time. So I write here declaration will be equal to minus 40 meter per second square. Part 2. The force due to air resistance acting on the skydiver immediately after the parachute open. Here we have to calculate the force. I consider that it's a skydiver and his weight is acting in downward direction, but there is also a force that is acting in upward direction and it is due to the air resistance. So there is also a force due to the air resistance. As skydiver is moving in downward direction, it means that his speed is changing in downward direction. So when I have to calculate the net force, I write W minus F air because weight is in the direction where speed is changes. So we have to calculate weight and also have to calculate F net. So here we have to find out due to the air resistance. So it will be equal to weight plus total force. So weight is basically equal to the product of mass and acceleration due to gravity, and F net, that is the net force, it is equal to ma. So mass is given in the question and its value is 76. So I write here 76, the value of g is 10 plus the acceleration we already calculate is 40. So the force due to the air resistance comes to be 3800 newtons. So this is a value of force that is equal to 3800 newtons. In the part B, explain in terms of forces acting on the skydiver his motion between t is equal to 0 and t is equal to 6.0 seconds. So we have to explain the force acting on the skydiver in his journey. Going back to the graph, here we can see that from the starting point to at that point, the speed is changing, but after that point, the speed is constant, it does not change. So, here we have to tell that why the speed is not changing and also discuss the forces on this region. So, first of all, I consider 2 points here, A and B. It's A point and it's B and C in the region from A to B. Here the speed is decreasing with time. It means that the skydiver decelerating and the net weight of is acting in downward direction, but there is also a force that is acting in upward direction, but its magnitude is very small. It's initially. So there is also a force that is acting in downward direction and weight is much greater than the air resistance force. So we can simply say that the air resistance increases with the increase in speed. So when time passes, speed slows down. It means that with the passage of time, the air resistance also decreases here. That's why weight is greater than the air resistance. In this region from A to B, the weight is greater than air resistance, and this is the basic reason why the speed here decreasing with the passage of time. So from B to C, the speed of body is constant. Speed is constant. It means that acceleration is equal to 0. And when acceleration is equal to 0, we know that net force on it must be equal to 0. In our case, net force is equal to W minus air resistance force, it will be equal to 0. So weight will becomes equal to air resistance. So from B to C region, the weight of skydiver becomes equal to the air resistance forces acting on it. So in this case, it moves with constant speed. I write here decelerates because upward forces greater than weight and air resistance reduces with decreasing speed. Finally, when weight becomes equal to air resistance, then the body moves with constant speed. Part C. Explain why opening the parachute cannot reduce the speed of skydiver to zero. So first of all, when speed is equal to 0, then the air resistance force must be equal to 0. Because air resistance increases with the increase in speed, when speed becomes equal to 0, the air resistance also becomes equal to 0. So on the skydiver, there is only one force that is acting in downward direction, and it is weight. So there is net force also acting on it, but its direction is same as that of weight. So at 0 speed there is no resistance and weight is still in downward direction. So I write here, at 0 speed there is no air resistance and weight is still downward. Question number 2. Figure 2.1 shows a wooden trolley of mass 1.2 kg at rest on a rough surface on a bench. So here is a trolley and there is a ball that is coming towards the trolley. A ball of mass 0.52 gram travels horizontally towards the trolley. The ball embeds itself in the wood of trolley. The trolley moves with an initial speed of 0.065 meter per second. Part A. Calculate 1. The impulse exerted on the trolley. Here we have to calculate the impulse that is exerted on the trolley. That's why we use the data for trolley. I write here the momentum. I write here the impulse I is equal to change in momentum for the trolley, and the change in momentum is also be equal to product of force and change in time. Here we have to calculate impulse and we use the first formula because we are given mass and velocity and not given the force and time. So I use that impulse is equal to change in momentum of trolley, and momentum is the product of mass and velocity. So I write here mvf minus mvi, where vf is the final velocity and vi is the initial velocity, and mass of trolley is given, that is 1.2 kilogram, 1.2, and vf, which is the final velocity, 0.065, 0.065. And we have to also find the initial momentum by multiplying mass with initial velocity. Initial velocity is 0 because the wooden trolley is at rest. So we multiply 1.2 with 0. And after solving this, the impulse comes to be 0.078 Newton second. The unit of impulse is Newton second. So I write here 0.078 Newton second. Part 2. The speed of the ball as it hits the trolley. Here we have to find out the speed, and for calculation of speed we use the law of conservation of momentum. Here are two things involved in this system, trolley and ball. That's why we have to apply the law of conservation of momentum in such a way that the total initial momentum of trolley and ball before collision must be equal to the total final momentum of trolley and ball after collision. So I write here total initial momentum of ball and trolley before collision must be equal the final momentum after collision. So before collision I write that mt, it is the mass of trolley, and vt is the velocity of trolley. And this is, first of all, I write for initial, that is after collision. So this is the total momentum of trolley after collision, and I also have to add the total momentum of ball. So it will be mb and vb. It will be equal to the initial momentum. So I write here mt and ut. The initial speed I represent it with u, and the final speed I represent it with v. So I add the momentum of ball, that is mb and ub. So here we have to calculate the speed of ball and we have to calculate ub. So by separating ub and by putting values, mass of trolley is given, which is equal to 0, 1.2, and from this line we can see that the ball embeds itself in the wood of trolley, and then this system moves with speed of 0.065 meter per second. It means that the velocity of trolley and ball after the collision is same. So I multiply it with 0.065 plus the mass of ball is given, that is 0.52, and it is given in gram. We have to convert into kilograms. So I write here 0.52 multiplied by 10 की power minus 3. It will be equal to 0.52 multiplied by 10 की power minus 3, and the speed is given 0.065. This is the final momentum of the system. Now we have to write the initial momentum also. So again the mass of trolley is 1.2 kilogram and it is initially at rest. So its velocity will be equal to 0 plus the mass of ball is 0.52 into 10 की power minus 3, and we have to calculate ub. So from here ub becomes as so I write here 1.2 plus 0.52 into 10 की power minus 3, and I take 0.065 common from the left hand side, and then I subtract. This term becomes equal to 0, so don't need to subtract this, and I divide it by this value 0.52 into 10 की power minus 3. So after simplification, ub, that is the velocity of ball, comes to be 150 meter per second, and that is the speed of ball. So I write here it is equal to 150 meter per second. Part B. As the trolley moves across the rough surface, it slows down and stops. Explain in terms of work done the energy change that takes place as the trolley slows down. So here we have to explain in terms of work that in which form of energy is changes. So first of all, as the surface is very rough, it is not smooth, it is very rough surface. So trolley has to do work against the frictional forces because there must be the frictional force present here. So the trolley has to work against this frictional force, and to do this work it uses its kinetic energy, due to which its speed slow down. So I write here it works against frictional force. By doing this work it uses its kinetic energy. It means that here kinetic energy reduce, it decrease. By decreasing kinetic energy, the speed also decrease. That's why it slows down and then at the end it stops. So I write here kinetic energy is used to do work against friction and so kinetic energy decrease and thermal energy produce. Question number 3, part A. Explain in terms of molecules why liquids are very difficult to compress. So it is very difficult to compress liquid. We have to explain its reason. So first of all, I consider a system. It's a container and there are liquid molecules inside this. The distance between these molecules are very small and these are very close to each other. So this is the first reason that the molecules are very close to each other and it is very difficult to compress because the molecules already touch each other. So I write here molecules are very close to each other. And second reason is that there are large repulsive forces between these molecules. So when there is a large amount of repulsive forces, it is very difficult to compress it. And I write here repulsive forces are very large between the molecules. Part B. Figure 3.1 shows a device that uses liquid pressure to lift heavy boxes. So this device uses the liquid pressure and it is used to lift the heavy boxes. So here we are given that the boxes are lifted by pumping oil into the cylinder. The force upward on the piston due to oil and the force downward on the piston due to the air. So it's a piston and upward force act on it which is due to the oil. So I write here this force is due to the oil while there is a downward force acting on it which is due to the air. So there is also the downward force acting on this piston, and this force is due to air. Combined to produce a constant force of 8800 newtons. The pressure of air is 1.0 into 10 to the power 5 Pascal, and the cross-section area of the bottom surface of the piston is 0.016 meter square. So here we also given the air pressure, and air pressure is acting in this direction, in the same direction as that of force due to the air. So the pressure of air is acting in downward direction. Part 1. Calculate the pressure of the oil at the bottom surface of the piston. Here we have to calculate the pressure which is due to the oil. So it means that we have to calculate this pressure. So there are basically two forces acting on this piston, that is upward force and one is downward force. The total force will be the difference of all of these forces, because the net force in upward direction, because this piston is moving upward, because it has to lift the boxes. So the net force must be acting in the upward direction. So net force will be equal to the force due to the oil and the force due to the air, the difference of both of these forces. So I write here F of oil minus F of air, the difference of oil, because here you can see that the direction of force which is due to the oil is same as that of the net force. That's why I write here the force due to oil minus the force due to air. So there are also two pressure. One is acting due to the oil and second is acting due to the air. So the net pressure will be equal to the pressure due to oil minus the pressure due to air. So in the question we have to calculate the pressure due to air. I separate it. Pressure due to oil will be equal to net pressure plus the pressure due to air. So we know that the pressure is equal to force per unit area. So net pressure, I write here F net divided by area plus air pressure is given and it is equal to 1.0 into 10 to the power 5. 1.0 into 10 to the power 5 Pascal. And this net force is equal to 8800, which is given here. It is equal to 8800 newtons. So I write here 8800 divided by the cross section is given, which is equal to 0.016 plus 1.0 into 10 to the power 5. So the pressure due to the oil comes to be 6.5 into 10 to the power 5 Pascal. So I write here answer that the pressure due to oil is equal to 6.5 into 10 to the power 5 Pascal. Next part, part 2. As the boxes are lifted, the depth of the oil increases. When we lift the box, then the depth of oil increases. Explain why the pump must exert an increasing pressure on the oil as the depth of oil increasing. So first of all, going back to the diagram. So when depth increases, it means that height increases. height increase. And this means that the level of piston is moving upward. I suppose that here the level of this piston comes at this position. So there are molecules below this piston. The number of these molecules increases because the depth increases here, due to which pressure also increases, that is exerted by the oil. So I write here, by increasing the depth, number of molecules increases. Also the pressure of oil increase. And to oppose this increase in pressure of oil, this pump, it must exert an increasing pressure. So I write here, pressure in the liquid increases. As depth increases. To oppose this increased pressure, which is due to the oil. So I write here pressure of the oil. The pump must exert an increasing pressure. Part 3. Suggest one reason why the force of 8800 Newton in Part B cannot lift the boxes of weight 8800 Newton. So going back to the diagram, and we can see from here that the net force is acting in upward direction and its magnitude is 8800 Newton. And in the last part it is given that the weight of these boxes is also 8800 Newton. So there is also the downward force which is equal to 8800 Newton in such a way that net force must be equal to 0. When net force is equal to 0, it means that there is no acceleration, and 0 acceleration means that speed is also equal to 0. Which means that we cannot lift the boxes when the applied force is equal to its weight. The applied force must be greater than weight to lift these boxes. So I write here, initial force has to be greater than weight, which is equal to 8800 Newton, to start motion. So if weight becomes equal to force, then there will be no motion. The boxes remains at rest. Question number 4. An aluminium saucepan with a plastic handle contains cooled water. Figure 4.1 shows the saucepan on a hot plate. Part A. State why the pan is made from aluminium but the handle is made from plastic. So here is the figure 4.1 and this is the hot plate. It contains a large amount of heat because its temperature is very large, and there is a saucepan in which we have water. And this saucepan is made up of aluminium while its handle is made from plastic. So why this is so? First of all, we can see from here that this hot plate is in contact with this saucepan. So we know that the temperature of hot plate is very large. It means that it contains a large amount of heat, and heat is transferred from one place to another. So some of heat from this plate will transfer to water. So by transfer of heat, the water molecule's energy also increases. And this transfer because that the aluminium is a good conductor, but this heat does not transfer to the handle because handle is a poor conductor. That's why the pan is made from aluminium while the handle is made from plastic. So I write here, aluminium is a good conductor of heat. While plastic is a poor conductor of heat. Part B. The hot plate is switched on, and as the temperature of the water increases, the internal energy of the water increases. Part 1. State in terms of molecules what is meant by the increase in internal energy. So first of all, here we have increased temperature due to which the internal energy also increased. So first of all, I consider that it's the saucepan and it is in contact with the hot plate. When this hot plate is switched on, then the temperature of water inside this saucepan increases. It means that temperature increases. As the energy is associated with temperature, by the increase in temperature, the molecule gains energy. Then molecule gains energy and they move very faster. When they move very faster, it means that their speed increases. Speed increases. And we know that kinetic energy is equal to half mv square. By the increase in speed, the kinetic energy also increases. So we can simply say that increase in internal energy means that the kinetic energy of the molecules increase. So I write here kinetic energy of the molecules increase. Part 2. Explain in terms of atomic lattice and electrons how thermal energy is transferred through the aluminium. So first of all, again I consider that it's the hot plate and it's the saucepan that is made from aluminium. And here we have to explain in terms of atomic lattice and electrons. And I consider that these are electrons and atoms inside this. So the atoms that are very close to hot plate, they break very faster. So they break very quickly. Why they break? Because they gain thermal energy from the plate. Because here plate is hot, its energy is transferred and this energy is absorbed by the atom that are very close to it, and then they break. And they start vibration. Due to their vibration, the energy is transferred to the free electrons, and free electrons move faster and they collide with each other. In this way, the thermal energy is transferred through the aluminium. So I write here atoms touching the hot plate vibrate faster. Atoms pass on vibration. To neighboring atoms. Atoms pass on vibration to electrons, and as a result electrons move. Part 3. Eventually the water reaches boiling point. Thermal energy from the hot plate is still being transferred to the water. Explain in terms of molecules the effect of this thermal energy on water. So finally the water reaches its boiling point. It means that its temperature becomes 100 degrees C. But still there is hot plate that transfer energy to the water. So we have to tell the effect of this thermal energy on the water. So when the water boils and the energy supplied by the hot plate, it is used by the water molecules to escape from water surface. So I consider that here is the water molecules and this hot plate transfer thermal energy. This thermal energy is absorbed by the water molecules, and when it is absorbed by the water molecule, then the water molecules try to escape from the surface, and in order to escape from the surface, these molecules first break their bond and to break bond they have to do work, and this work basically appears in the form of gain in potential energy. So I write here by breaking the bonds between molecules, the molecules escape from water surface and they gain potential energy. So next part. The mass of water decreased by 0.11 kilogram in 300 seconds. The specific latent heat of vaporization of water is 2.3 into 10 to the power 6 joule per kilogram. Calculate the rate at which the water gains thermal energy. Here we have to calculate the rate of thermal energy gain. It means that we have to calculate power, because power is the energy per time. It is power. We have to calculate power. So we know that energy is equal to the product of mass and latent heat of vaporization LV. And here we have to calculate power. So I divide with T on both sides. I write here dividing by time T on both sides. So it becomes E over T will be equal to MLV over T, and it becomes power, that is the rate at which the water gains thermal energy. So by putting values, mass is given 0.11 multiplied by the latent heat of vaporization is 2.3 into 10 to the power 6, and time is given 300 seconds. So the rate becomes as 840 watt. So I write here 840 watts. Here we calculate power. The unit of power is watt. Its unit is not joule, because the unit of energy is joule, and here we calculating power. That's why I write watt. Question number 5. Figure 5.1 shows the structure of liquid in glass thermometer. So here is a figure 5.1 and it is a liquid in glass thermometer. The bulb of the thermometer is placed into a beaker of warm water. As the liquid expands, it moves along the tube. Part A. Explain in terms of molecules why a liquid expands when heated. So the liquid expands on heating. We have to explain it. So first of all, I consider a beaker. And inside this, there are liquid molecules. So when we increase its temperature, then the kinetic energy of liquid molecule increases. So I write here kinetic energy increases, due to which these molecules move with greater speed. So they move faster and collide with each other. So due to their larger speed, the molecules move apart. So in this way, the volume increases and we can simply say that the liquid expands. So I write here, molecules gain kinetic energy. And molecules moves further apart. Part B. Explain in terms of molecules why a liquid expands more than a solid when heated. So, when we supply heat to liquid and solid, then the expansion in the case of liquid is larger as compared to solid. We have to explain this. So again, this is a solid, this is a liquid. And again I make solid. We know that the molecules are solid are very close to each other as compared to liquid. So, in this solid, the force of attraction are very large. Force of attraction for solids are very large as compared to liquid. It means that liquids have smaller force of attraction. So force of attraction for liquid is smaller. So less amount of energy is required to separate these molecules, or less energy is required for the expansion of liquid as compared to solid. So it is easy for us to expand liquid as compared to solid when we heat it. So I write here forces between liquid molecules are weaker as compared to solids. And less energy is required to separate molecules. Part C. A second thermometer has a larger bulb that contains more of the same liquid than the thermometer shown in figure 5.1. It has a different scale. In every other way, it is identical. Part 1. Explain how the sensitivity of second thermometer compares with the sensitivity of thermometer in figure 5.1. So we have to compare the sensitivity of both of these thermometers. The difference between these thermometers is that the second thermometer has large bulb and it contains more amount of particles. So as the bulb is larger, it means that the size of thermometer is large. Size is large for second thermometer. The size is directly related with the sensitivity. The greater the size, greater will be sensitivity. I write here, size is directly proportional to sensitivity. For the thermometer whose bulb is of larger size, its sensitivity will be more as compared to the bulb of the thermometer whose size is smaller. So I write here, first of all, greater sensitivity. And there is also the amount of liquid that is larger as compared to the first thermometer. So amount of liquid is larger. It means that the volume increase. And volume increase means that the more molecules are present here. And these molecules then move greater distance. Greater molecules are present there and they move greater distance. So I write here, Because liquid moves greater distance for same temperature change. Part 2. Explain how the range of second thermometer compares with the range of thermometer given in figure 1.1. Here we have to compare the range of both of these thermometer, and we know that the second thermometer has a greater size of bulb, so its range will be smaller because the size is inversely proportional to the range. So the greater the size of bulb, smaller will be its range. I write here small the range, liquid will expand more. And has tube of same length. Next part. Part D. 1. State one everyday problem that is a result of thermal expansion. So in the thermal expansion, we know that temperature increases. If we talk about the bridges, then when the temperature increases, there will be the expansion in bridges and the bridge buckle in hot weather. So I write simply that bridge buckle in hot weather. Part 2. Suggest and explain one way of solving this problem, how we can tackle this problem. So we allow at the ends of the bridge gaps. So I write here by allowing the gaps at the ends of bridges. When bridge expands, the gap gets closed. So there will be no issue. I write here allow gaps at the ends of the bridge when bridge expands. The gap close. Question number 6. Figure 6.1 is a full-scale diagram that represents a sound wave traveling in air. Here is a figure 6.1 and this is the direction of travel of wave. Part A. On figure 6.1, mark 2 points, each at the center of a different compression. Label both of the points with C. So first of all, we have to know about the compression. A wave consists of two parts. First is compression and second one is rarefaction. Compression are the portion of the wave where the particles are closer to each other. So in this way we can see that at these locations the particles are very close So these are basically the compression. I write here the portion of wave where particles are closer, and rarefaction is the portion of wave where the particles are far away from each other. In this region you can see that the particles are very away from each other, so this region is basically rarefaction. I write here the portion of wave where particles are far away. So in the question we have to label the portion of the wave which is compression, and we know that in the compression the particles are very close to each other, so these are the compression. Here this is the compression and this is the compression. In the question we are asked two portion, so we also have to label it with C. I place a dot here because we have to place 2 points on the compression. So I second place here. These 2 points are compression and label it with C. Part B. The speed of sound in air is 330 meter per second. Measure the diagram and determine the frequency of sound. Here we have to calculate the frequency of sound. When the speed of sound is given and wavelength we have to calculate from the figure. So first of all we know that the formula V is equal to F lambda. Here V is speed, F is frequency and lambda is wavelength. Here we have to calculate frequency. So I write this equation F is equal to V over lambda. V is given in the question, it is 330 meter per second and wavelength is not given. We have to determine it from the figure. So by using ruler, we can determine the wavelength, and wavelength is basically the distance between two consecutive compressions or rarefactions. So I measure the distance from this point to this point, and this is basically equal to wavelength. By using ruler I measure it and it becomes to be almost 5.2, and this is in centimeter. It is 5.2 centimeter. First of all I have to convert it into meter. So I divide it by 100 and it becomes 0.052 meter. So wavelength comes to be this from this figure. So by putting values here, 0.052, frequency comes to be 6300 Hz. So this is the frequency of sound. I write here frequency is equal to 6300 Hz. Next part. So here is another figure. In the part C, the wave reaches a barrier. You can see it's a barrier and wave reaches at barrier. Figure 6.2 shows the wave passing through the gap in the barrier. So there is a separation in this barrier and the wave is passing through this separation and goes on the other side. The frequency of the wave is increased. Here we have increased the frequency to a value many times greater than the value obtained in B. So in the previous part, the frequency comes to be 6300 Hz. But in this part we have increased the frequency of wave and it must be greater than 6300 Hz. Describe and explain two ways in which a diagram representing the wave will the greater frequency differs from figure 6.2. So going back to this figure, here you can see that in this figure, when we increase frequency, then by relation V is equal to F lambda. Speed is constant, it is 330 meter per second, it is not changing, which is the speed of sound. And when we increase frequency, then wavelength should be decreased. And you can also see from this figure that as the wave approaches towards the barrier, its wavelength going on decrease. And we have to find out the ratio of wavelength of this wave to the gap between these barriers. So, when this value is larger, it means that diffraction will be greater. So, when this value is larger, the diffraction will be greater. When this value is smaller, the diffraction will be smaller. In this figure, when the wave passing through this barrier, it diffract, means that it bend into the circular path. So here we can see that the wavelength goes on decreasing. It means that this ratio, the wavelength of wave and gap also decrease. So I write here this ratio, wavelength over gap decrease. And when this ratio decrease, the diffraction will be less. So I write here first point, less diffraction because of smaller ratio of wavelength of wave and the gap width is less. So we also have to write second point. Going back to the diagram again. Here we can see that the frequency is greater, then its wavelength should be smaller. It means that the distance between the compression is reduced because the wavelength is actually the distance between two consecutive compressions or rarefaction. When wavelength is smaller, the distance between the compressions will be less. The first compression is this, while the second one is this. First of all, the distance between them is this. But again, you can see after the diffraction, if you considered it as a compression and this is also compression, the distance goes on reducing with the reduce in wavelength. So the compression and rarefaction will be closer as lambda increases, as lambda decreases. So here when we increase the frequency, then its wavelength goes on decreasing. I write here wavelength decrease. Decrease of wavelength means that the distance between two compressions or rarefaction is reduced. So, first of all, on the left side, these are the compression and the distance between them is this. So, as the wave moves towards the barrier, then the distance between them reduces and the compression and rarefaction will get closer. So, I write here compressions and rarefactions will be closer as wavelength reduces. Question number 7. Figure 7.1 represents an alternating current AC of generator. Part A. A student rotates the handle H as shown in figure 7.1. Part 1. On figure 7.2, sketch a graph to show how the electromotive force EMF between terminals X and Y varies with time during two complete revolutions of the coil. So in figure 7.1 we can see that here is a handle H and these are the poles of magnet, north pole and south pole, and in this direction the coil is rotated. These are two terminals X and Y. In the part 1 we have to draw the electromotive force between the terminals X and Y that varies with time. So first of all, we know that when the coil is rotated in the magnetic field, then there will be the induced current. And when there is induced current, there will be the production of induced EMF. So first of all, I draw the waveform and describe the different position of the coil in which the EMF and the current is maximum and minimum. So it's the shape for this is sinusoidal. So I draw here and this shape I suppose that it is EMF and here is time. From this we can see that at this point the EMF is maximum and it also changes its direction and it becomes maximum in negative direction, then again becomes maximum in positive direction, and it also becomes equal to 0 at this point. It means that all of these values of EMF depends upon its orientation, that in which direction we have placed the coil in the magnetic field. So first of all, I consider that the magnetic field is in this direction. It is the horizontal direction of magnetic field. And I consider that the coil is placed vertically. Now when this coil rotates, it will rotate in this direction. So when it rotates, there will be no cutting of magnetic lines of force. If I replace this coil in the magnetic field, it will be just like this, and when it rotates, there will be no cutting of magnetic field lines. It means that when there is no cutting of magnetic field lines, the induced current will be equal to 0. As a result, the EMF will be equal to 0. It means that when I place the coil in vertical position to the magnetic field, then the EMF will be equal to 0, which is represented by this point. Second, I change the position of this coil and replace it horizontal, just like this. I am replacing here. Then, when it moves, it touches the magnetic lines of force and cut them, due to which there is the induced current, and as a result there will be the induced EMF. So, when in horizontal position, then induced current is also present and also EMF here present. It means that EMF is not equal to 0, it is maximum and it is represented by this point. No, I consider that this coil again rotates and this figure, the upper side becomes lower and lower side becomes upper, just like this. Then it is again in vertical position. So again the induced EMF and the current will be equal to 0 and it is represented by this point. When this coil again rotated and come in horizontal position such that this right side becomes left and this left side become right. So this is again in horizontal position, and in horizontal position there is induced EMF and it will be in opposite direction, but its value is maximum. So in this way, by the changing the position of coil in the magnetic field, the induced EMF and induced current changes. So here we have to draw for 2 complete revolution, which is given in the question. So we have to draw 2 sinusoidal wave. So it will be like, I will draw here when the coil is in horizontal position and when it is in vertical position. First of all, it is in vertical position and its EMF will be equal to 0. And I will draw it as so this is the sinusoidal wave and the EMF between terminals X and Y. On the Y-axis here is EMF and on X-axis here is time. So at that point the EMF is minimum and at that point EMF is maximum. By drawing this curve, we have to take care that the time period and amplitude will remain same. It means that the distance of this top point from the main line will remain same for all the cycle. It will be same for this one and for the all others. And the time taken by this to complete one revolution will be same. Time period and amplitude remains the same. So moving towards the next part. Part 2. On figure 7.2, mark and label a point P for the EMF when the coil is in horizontal position as shown in figure. So when it is in horizontal position, it means that it cuts the maximum number of magnetic lines of force. So in horizontal position, cuts maximum lines of force. As a result, the induced current will be maximum and the induced EMF will be maximum. So we have to label the point at maximum EMF, and it will be at this point and at this point. We have to show this with P. Part 3. The student turns the handle more quickly. State two ways in which the EMF between the terminal X and Y changes. So here, going back to the diagram. So when the student turns this handle very rapidly, then it means that the cutting of magnetic lines of force must be greater, because we know that EMF is directly proportional to cutting of magnetic field lines. Which is represented by phi. When there is maximum cutting of magnetic field lines, EMF will be larger, and in this way there will be a larger EMF as compared to the first one. It means that its amplitude may be increased. If I suppose that first of all it is 2, then its amplitude increases because EMF here is greater. So I write here amplitude increases and EMF changes direction more often. Next part. Part B. Terminals X and Y are connected to the primary coil of the transformer. State and explain what happens in the transformer as the student turns the handle of the AC generator. So going back to the figure again. So here we connect the transformer with these terminals X and Y, and I'm connecting here. There is primary coil. A transformer consists of two coils, primary and secondary, and this is secondary coil. And we know that these coils are connected magnetically. When current flows through the primary coil, because when rotate the coil, AC current flows through this, and this AC current when flows through the primary coil, then there will be the production of magnetic lines of force. It will be just like this, and these magnetic lines of force also passes are linked with the secondary coil, due to which there will be the production of current in the secondary coil. It means that we have induced the current in the secondary coil because the magnetic lines of force are linked with the secondary. So when there is the induced EMF in the secondary, induced current in the secondary, as a result there will be the induced EMF. So I write here AC current in primary primary coil alters magnetic field around primary coil. Magnetic field lines cut secondary coil. There will be induced EMF in the secondary. Part C. Explain why the power losses in transmission cables are lower when electrical energy is transmitted at higher voltages. So first of all, the resistance of cable may be constant, and we know that power loss is equal to I square R. When R, that is resistance, it is constant, then we can reduce the power loss by reducing current, because here R resistance is constant. And we also know that P is equal to product of current and voltage. When the current decrease, then the voltage should increase. To maintain this power. So I write here, smaller current result in less thermal energy loss. Smaller current results in less thermal energy loss. Question number 8. A student sets up a circuit that includes a 12-volt battery, an 800 ohm resistor, a voltmeter and a thermistor. Figure 8.1 is an incomplete circuit diagram because the symbol for the thermistor is missing. The thermistor is connected between terminals P and Q. Part A. Complete figure 8.1 by drawing the symbol for a thermistor between terminals P and Q. Here we have to complete the circuit by drawing the symbol of thermistor. So first of all, the symbol of thermistor is same like that of resistor. So I draw it here. And now I have to join both of these. So you also have placed a line. This is the symbol for thermistor. Part B. The 12-volt battery consists of 8 identical cells connected in series. So here we have connect 8 cells and these are connected in series. This is first cell, second, third, 4, 5, 6, 7 and 8, and it forms a battery whose voltage is 12 volts. Calculate the electromotive force EMF of each cell. We have to calculate the EMF of each of these cells. So we know that EMF will be equal to total voltage divided by total number of cells. I write here EMF will be equal to total voltage divided by total number of cells. So here total voltage is 12 and there are 8 cells, so I write here 8. It will be equal to EMF and it is 1.5 volts. So EMF comes to be 1.5 volt. Part C. The reading on voltmeter is 8.0 volt. So here the voltmeter gives reading 8.0 volt. Part 1. Determine the resistance of the thermistor. We have to calculate the resistance of this thermistor. So going back to this diagram, we can see here that the thermistor and this voltmeter are in parallel, and this parallel combination is in series with 800 ohm resistance. So I just write here series and parallel combination, and now I make a table. First of all current and second one is voltage. In the series combination, voltage is different. So I write here voltage is different, and in the series combination current is same. In the parallel combination, current is different but potential remains same. So using this concept, we see that voltmeter and thermistors are connected in parallel, and in the parallel combination we can see that the voltage remains same. It means that if 8 volt is across this voltmeter, then the thermistor also have 8 volt. The voltage across both of these components will be same, and here we have to find out the resistance of this thermistor. For that we use Ohm's law. V is equal to IR and R is equal to V over I. We know the voltage across this thermistor but don't know the value of current. So first of all we find out the value of this current. And in the circuit we can see that the EMF is 12 volt and 8 volt is dropped across the thermistor, and all of these are the potential of this 800 ohm resistor. So I simply write it as 12 volt will be equal to the potential across 800 ohm resistance plus 8.0 volt, that is drop across the thermistor. So here we have to find out V800, it comes to be 4 volt. So the potential across this is 4 volt, and we can easily find out current here by using I is equal to V over R. So here 4 divided by 800, current comes to be 0.0050 amperes. So this current is basically across this resistor and it is 0.0050 ampere. From this table, we can see that the current in series combination remains same. It means that the voltmeter and thermistors are in parallel combination and this parallel combination is in series with 800 ohm resistor. So the current that is through 8 ohm resistor will be same as that the current through this combination. But we know that the resistance of this voltmeter is very high because it measures the potential difference and in order to measure the potential its resistance should be very high. So practically no current pass through this. So all of the current will passes through this thermistor. We can simply say that the current through thermistor will be equal to 0.0050 ampere. So I use this value of current to find out the resistance of this thermistor. So R comes to be V is 8 and current is 0.0050 and it comes to be 1600 ohms. So this is the resistance of this thermistor. I write here 1600 ohms. Part 2. A few hours later, the student noticed that the reading on the voltmeter is greater. Explain what can be deduced from this observation. So going back to the diagram. As the potential across this voltmeter and thermistor is same, if a student noticed that the voltage across the voltmeter increase, it means that its value should be greater than 8. Then what will happen? The voltage across this thermistor also increases. It means that if the voltage across the thermistor increase, then it is only possible if the resistance value of thermistor is increased. It means that the resistance across this thermistor increases, and resistance of thermistor increases only when there is small temperature. When we decrease temperature, so their temperature should be decreased. So I can simply write as we can deduce from this observation that larger voltage across the thermistor second one is resistor of thermistor is larger. And this is only possible when the temperature of thermistor small. So I write here temperature of thermistor must be small. Question number 9. There are 3 naturally occurring isotopes of hydrogen, that is hydrogen 1, hydrogen 2 and hydrogen 3. The nuclide notation for hydrogen 1 is H, 1 and 1. It means that hydrogen symbol is H and this lower one represents the atomic number while the upper one represents the atomic mass. Part A. Write down the symbol using nuclide notation for hydrogen 2 and hydrogen 3. So first of all, we have to know about what is isotopes. Isotopes are those elements that has same atomic number but different atomic mass. That has same atomic number but different atomic mass. When we write the symbol of any element, let's suppose it is represented by X, and at this location we write atomic number and it is represented by Z, while at this location we write mass number and it is represented by A. So here we have to write out the symbol for hydrogen 2 and hydrogen 3. So hydrogen 2 is basically represented by H, and I already said that all of these are the isotopes of hydrogen, so their atomic number must be equal to 1. I write here 1. And what will be their atomic mass? Their atomic mass will be different, and it is given that hydrogen 2 and 3. So I write here 2. And when we have to write the symbol of hydrogen 3, I write again 1 because the atomic number remains same, but the mass number here is 3 because it is for hydrogen 3. Part B. In a fusion reactor, a nucleus of hydrogen 2 and nucleus of hydrogen 3 undergoes fission. State what is meant by nuclear fission. So nuclear fission is a process in which small nuclei combine and give us a big nucleus and a large amount of energy released here. So I write here fission, the process in which small nuclei combine to give large nucleus with a large amount of energy and a large amount of energy release. In the part B, the fusion reaction produces a free neutron and one other particle. So here the fusion of hydrogen 2 and hydrogen 3 produce another particle, one free neutron. So write down using nuclide notation the equation that represents this reaction. We have to write a chemical equation for the fission of hydrogen 2 and hydrogen 3 in the form of free neutron and other particle. So I write here first of all hydrogen 2 and 1 plus hydrogen 3 is represented by 3 and 1. Both of these fuse together and give us single particle and free neutron. So free neutron is represented by this symbol, while we have to guess at which element present here. I first suppose that it is represented by X. So I have to write the atomic number and atomic mass of this element. So I check the atomic number and atomic mass on both sides of this equation are equal. So first of all, left hand side must be equal to right hand side. First of all, I check the atomic mass. So it is represented by A. On the left side, here is 2 and 3. So I write 2 plus 3 will be equal to, here is 1. So I write 1. So which thing I add here? To make both of these sides equal, there should be 4. So that 5 it will be equal to 5. So I write here 4. Now I am going to check atomic number that is represented by Z, and the atomic number of this and this is 1 and 1. So 1 plus 1 will be equal to, neutron has atomic number 0, plus which thing I add here to make both sides equal. So I add 2 and it becomes 2 is equal to 2. So the atomic number and atomic mass of this unknown particle have determined, and now we have to guess the name of this particle. Helium is particle whose atomic number is 2 and mass number is 4. So this X must be replaced by He, that is the symbol of helium. I write here He. So this is the balanced chemical equation. Part C. Nuclear fission in Sun is the source of most but not all the resources that are used to generate electrical energy on Earth. State 2 resources for which nuclear fission in the Sun is not source. So first of all, we can use the energy that is obtained from the nuclear fission, because there is a large amount of energy released in this reaction, and we use this energy to generate electrical energy. So we have to explain the other 2 resources from which we can also gain electrical energy, and we can obtain this energy from geothermal energy. So I write here geothermal. This energy is obtained from the earth. By the name, geo means that earth and therm mean heat. So this energy is basically obtained from the earth. And second one is nuclear energy.